So the easiest way to write that would just be x is greater than or equal to, because it is equal to 0. Okay, and it's really just going to be wherever this starting point is. On the on the parent function, it starts at 0. But we'll see once it moves around, once we do the transformations, it's going to start at wherever that beginning point is. Okay, with the range, it's the same thing on this. It's starting at 0 here and going up, so it's y is greater than or equal to 0. Okay, but again, that's only for the parent function. We'll see when some move around that will change. Okay, but it's going to just be wherever the starting point is going to be the number that you need. Whereas cube roots, since it goes right and left forever, what does that mean the domain's going to be? Okay, it's going to be all real numbers. Okay, we're going to use the all real number symbol. Hopefully you remember what that means. Since it's going on this way to infinity, this way to negative infinity, that's all real numbers. Okay, and range will be the same thing. Okay, it really looks like it's just going right and left, but it is kind of slightly going upward. Okay, and slightly going downward. So the range, the y, will be all real numbers on that one as well. Okay, every cube root function will have the same domain and range. Okay, square root functions, you'll have to actually look and see where did this starting point go to. Okay, and I'll show you when that's going to move around or when that's going to change here in a minute. Okay, so we're going to look at number 1 and number 2. They want us to graph it. They gave us a little graph. It's going to be the only ones that we're going to graph today. The other ones we'll do a sketch like we've been doing in the past. Just a little sketch. It doesn't have to be perfect, but here we are going to graph it perfectly so that you can really see what you need to see. And the way that we did that, if you remember, is we put it in y equals. Right, this is the parent function, so we're just going to just only graph this function with these transformations included in it. It is a square root. There's no number there. That means it's a square root. You can put a 2 there if that helps you. It's like everybody knew that was a square root before I taught you other roots, and then people forget. Okay, so the way that I'll do it is go to y equals second square root x plus 3 underneath there. Okay, but then I got to move the arrow over and get out from underneath the square root and then do minus 2. Okay, I want to push graph. Now I want to point out, we've talked about transformations before, okay? And with transformations, we usually say parentheses, okay? But here, there's not parentheses, there's a square root sign, okay? So we should kind of know, if it's outside, what is this minus 2 going to do, okay? What does the minus 2 on the end do? It's going to make it move down 2, right? And this plus 3, okay, it's inside the square root, okay? There's no parentheses, but it's inside the square root instead of parentheses. Inside plus, remember that means it's going to move left that many, okay? Left 3. And if I look at this graph, we know it started at 0, 0, the parent function. And here, if you look and see, it moved left 3, down 2, okay, where it started out at. And we're going to want the exact points on here. Right, we don't just want to slop it on there. We want the exact points. Okay, so what I'm going to do is I'm going to just draw my x and my y axis right in the middle here. There's my y. Here's my x. And you can see, like I said, well, since it moved, because we put these in here, if you go back to negative 3, negative 2, okay, left 3, down 2, there's a point there, negative 3, negative 2. But everything to the left of that, error, 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 okay? It does not have it because there is no graph there, okay? That would be anything to the left of this part on the parent function. So we'll do negative 3, negative 2, negative 2, negative 1. And let's see, let's skip these decimals for now and see if we have any better ones. If we didn't have any other better points, we would try to plot the decimals, but since we've got 1, 0, I think that's kind of going to, 3 points is probably going to be enough. We can see, okay, it starts here, and it goes up like that. Okay, that's what our graph is going to look like. And remember, if it's only part of it or half of the graph going one direction, that's a square root. Okay. And our domain, that's our x, right? And range is our y. Well, here it started at 0, 0. Okay, 0, 0. This one is -3, -2. Okay, that's what this point is right here where it starts. So those 2 points are going to be our domain and range. Okay, remember, this is x, that's y. And since it's going this direction to the right, it's still going to be x is greater than or equal to, but it'll be -3 because it's anything greater than -3, there's a graph there. Okay, same thing here. Since y is going up into the right, this will be y is greater than or equal to -2. Okay, that'll be our domain and our range for that. It just depends on where we've moved the graph around. It only depends on if it moves up and down and left and right. Okay, if there's stretches and shrinks, that first point, the original point, will be in the same place.